Welcome to the Session 8 on fostering exploration success in Europe with the cutting-edge technologies. The mining industry is at a crossroads, facing increased demand for raw materials while being challenged by the need to operate sustainably. The pressure to extract minerals from greater depths and in increasingly complex environments requires us to rethink traditional mining methods. In this context, the integration of advanced technologies will be a game changer, allowing us to transform Europe into a sustainable, resource-efficient and competitive economy. Today, we will hear about several groundbreaking projects that exemplify how technology can drive exploration success while addressing environmental.
Okay, I believe this will be the session where we'll be testing the coffee. I mean, everyone had a coffee, and if you are still alive and kicking, because it's the last session, I'll be very pleased. So it's my honor to be the chair of this session, and we'll try to make it effective and delivering interesting solutions and information to everyone. The first speaker is Marko Komac. We work together in several projects, but Marko will be talking about the future, right? So Marko, if you want to join us and just kick off this last session, you are welcome. Thank you.
Thank you, Vitor, for this short and informative introduction. My name is Marko Komac, and I'm representing Intro as a project partner in one of the interesting European Horizon projects called Persephone. So what is the content of my presentation? First, I'm going to run through the rationale. I'm going to go through the project overview, the objectives, and then expected outcomes. I will also present you with some interim results, because project only started January this year, so we still have more than 2 years ahead of us, but we already have some really interesting outcomes. We've all heard in the past couple of days that Europe is facing a big challenge regarding critical raw materials. The surficial ore deposits have been mined, and we need to go much deeper, and that brings along huge challenges. Challenges that probably humans cannot obtain for up to from specific physical descriptions. So what we are doing in this project is that we've sort of, from different parts of Europe, put heads together to try to come up with some clever ideas how to address this. And we've sort of met and discussed, brainstormed how to proceed. What are those key challenges that we can address based on our knowledge? This is the team or the project consortium compiled of 12 project partners coming from 8 countries, and also not only from Europe, also from Africa. So what did we brainstorm about? First of all, we definitely need to address something novel, something new. Bring into the mining some of the perspective or science domains that have not been used. They have been thought about, but not really used in the past. And since one of our partners is quite advanced in automation and robotics, the idea was to dive into that domain of potential future mining. And one of the project overviews was to sort of develop an autonomous solitaire, or in the fleet, autonomous vehicle, or let's say a robot that would help us explore and potentially even exploit future mines. So what is the concept and the vision of the project Persephone? We want to reduce the machines that are currently used in mining. So from those large machines, go to as smaller ones as possible. And with that, there are several beneficiaries or benefits that come out of it, not only reducing the size of the excavated material, but also with that, reducing the size of the waste, the processing time, the exploration time, etc. And all this, of course, needs to be backed up with some sort of technology, not only from the robotic perspective, but also from the data processing perspective, and developing some sort of digital twins that will help us understand more clearly how the mineralization occurs, where to follow it, how prosperous it is in specific areas of potential mine. And since we've come up with this idea, we've applied it, and we got a project within Horizon Europe. And the project runs until the end of 26. It has roughly 5 million. And the leading partner is the Swedish University for Technology far up north, that already does some really interesting robotics for the mining, of course, on the testing scale. So this is just the work package organization. You see the coordination and then different work packages. It's quite complex nowadays because we have a lump sum projects, and that it's a bit of headache. Anyhow, we've split our teams into 4 innovation teams. One is dealing with innovative drilling techniques, another one with raw materials characterization on site, the third one with the autonomy challenges of such robotic tools. Either, as I said, solitary or in fleets. And the fourth one is, it's called supporting system, but basically deals with the data processing and preparing or modeling the proper or as good as possible digital twins that represent the reality underground. So there are several research pathways that we've wanted to address. The first one is sort of grouped in the integrated system for the on-site tool, that is the robots. And these robots, like you can remember from the innovative teams, will address different issues. And first of all is, of course, scaling down the size of these machines, robots. And you'll see later on that we are in quite a good way, not completely satisfying all the demands because of the size. This is very small, rather small, I would say. So it doesn't address some of the issues that mining is facing, but still it helps to address most of them. And then the second research pathway is of autonomy, which is, to us, being mining and geosciences related experts, a bit far away or a bit science fiction, but still it's very interesting. And the third one is in situ measuring or sensing. Many of you are here experts from those areas, and you would see this quite interesting when we have some more outcomes. Once we developed this and integrated them into our robot, as you will see later on, we will test this technology in 2 sites, one in Greece and one in deep mine in Sweden. And the second and the third area that we combined in second group would be the data integration, interoperability, processing, and then modeling of this data, because that's also important if we want to have near real-time or real-time information where and how to further exploit or explore or drill. So this is the first result. As you can see, it's a dog-like robot, and it can carry 80 kilos of equipment for detecting, processing, and sampling. So it's quite advanced. It looks a bit clumsy, I would say, for now. But believe me, on site, it does overcome challenges of mud, let's say shallow to relatively, let's say about 10 centimeters mud, water, and other specific challenges. Obstacles are still, larger obstacles are still quite challenging for us. But that's, of course, the first result. So what are the benefits that we see out of our final result? Not yet, but we will introduce the innovative technologies for the extraction of raw materials. And in addition to the political support of domestic EU sourcing of raw materials, technology is also very important because it reduces all the waste, all the emissions, and people are also very sensitive to those emissions. And of course, we want to integrate all the data with the existing standardization of classification of raw materials. And with all that, we want to contribute to acceleration of the extraction of raw materials in Europe. What is really important for the industry in mining industry is that with introducing such techniques, we elevate the health and safety standards for the employees on site, because less frequent visits to the dangerous parts of mines or shafts are necessary. And of course, the consistency and data processing is much better. There are still some challenges within the consortium that we need to address, because some of the partners are inclined to coreless coring technology, which, being a geologist and having post festum access to drill cores, it bothers me a lot. So we are still discussing that. I think that at the end we'll find a common and sensible solution. Anyhow, that was one of the ideas. And of course, also the benefits are others dealing with the efficiency, the effective data integration, and also reducing costs in extraction and sampling. And with that, I think my presentation is more than on time, and I thank you for your attention.
Thank you, Mark. We'll be having the questions at the end. I guess we'll be having several questions to you, because we are just raising robotics, and I wonder if people will be complaining about having robots replacing miners. Okay, let's now talk about two other projects coming from a talk by Veronika Sradnova from the Czech Geological Survey. Thank you, Veronika, please.
Good afternoon. So my name is Veronika Strnadová, and I will be speaking about two European projects from the Horizon Europe program. Let's start with the first one. It's called Multi-Miner. What Multi-Miner stands for? It is multi-source, multi-scale of observation and innovative machine learning for mineral exploration and mine site monitoring. So you can see quite difficult title to remember, so let's stay with Multi-Miner. To make it short, Europe needs to secure sustainable supply of raw materials while reducing dependency on the countries outside Europe. In this way, Multi-Miner can play an important role, as it is proposes to improve mineral exploration and mining site monitoring practices through generic but highly innovative machine learning solutions when using, let's say, contactless and non-destructive methods and distance data, means data acquired remotely. So this project started January last year, and it's been running for 42 months. Who are the partners? There are basically 12 partners and one associated partner. More specifically, we have 7 research institutes, 2 academia, 1 consulting business company, and 3 mining companies. It is truly interdisciplinary, as it combines backgrounds in geology, remote sensing, or machine learning. And the project coordinator is GTK, Geological Survey of Finland. So under multi-miner, we have been developing algorithms, and we will demonstrate them in 5 European test sites to then demonstrate its, let's say, easy use in different environments. We have one site in Finland, it's called Inhalayan, one site in Austria in Hochfilzen, and 3 sites in Greece, Chalkidiki, Kalinteri, and Kirki. So, as already mentioned, we have been integrating data or of observation data that's been acquired by different platforms. That means drone-based or aerial data, as well as orbital, I mean satellite data. We employ unsupervised or weakly supervised machine learning methods to develop innovative applications for mineral exploration, mine site monitoring, and even for closure and rehabilitation. More specifically, we have been focusing on developing innovative solutions for mineral mapping and multi-scale data interpretation, as well as for ground moisture monitoring, dust monitoring, water quality and acid mine drainage monitoring, and biodiversity monitoring. All these thematic applications rely on satellite imagery available through the Copernicus program, as well as the other ones. And in situ data have been used to, let's say, train the models and also validate the results. Most of the applications use drone imagery that is used to that it's been used for upscaling in situ measurements to satellite data resolution. Now, looking in more closer way on Earth observation data, we integrate low to medium, even to high resolution satellite data together with data we acquire by the airplane or drone. And this helps us to leverage diverse multispectral and hyperspectral data together with radar data acquired at different frequencies and different spatial resolutions. Besides that, we also acquire proximal or close range remote sensing data to cover even the most detailed scale with, let's say, with the information of the highest accuracy. So now I'm coming to, let's say, to show you some examples of the products that have been developed under this project. So here you can see a result of, let's say, semi-quantitative mineral mapping using hyperspectral scanning of the mine wall. These, let's say, high resolution and high spectral resolution data allow for a detailed mineral mapping and differentiation. So in this case, we were interested in magnesite and dolomite and map these abundances. Also, we develop a wizard or a toolbox for mineral prospectivity mapping. And here you can see the example or how the interface looks like. So the user can import diverse Earth observation data, can also upload the in-situ data, can select what type of modeling want to employ, and decide about the desired product, such as, let's say, mineral abundance map or more advanced product, such as alteration zone map. We also develop, let's say, monitoring systems for environmental monitoring. So we work on the acid mine drainage and water pollution. We basically take it as a complex issue, and we aim to accurately map the acid mine drainage discharge together with the consequent water pollution. To be able to do that, we basically use satellite data from the Copernicus program. These data are available for free and at the multi-temporal, let's say in a multi-temporal way. And these data allows us to detect acid mine drainage hotspots. For these hotspots that have been detected, we use high spatial and spectral resolution drone data to resolve the mineralogy and water pollution in further detail. We also work on the dust monitoring, let's say dust monitoring topic. So we divided it into 3 processing streams. First one is focusing on detecting mineral dust sources. For that we use satellite hyperspectral data that allows us not only to define the extent of the mineral dust sources, but also to resolve the mineralogy. We also model the transport of the dust through the atmosphere. For that, we use completely different kind of data. That means data they are acquired at a high temporal resolution. We need to have basically 1 image per day. And we also study the interactions between the atmosphere and the vegetation. For that, we again work with multitemporal and multispectral data that allows us to assess the status of the vegetation. So there is indeed not so much time to go in detail. So you can follow us or follow the multi-miner project. You can check our website. You can subscribe the newsletter. So in that way you will get updated information every 3 months. And we are, of course, also on LinkedIn or X, former Twitter. Yeah.
Thank you so much, Veronica. You have another project to tell us about, right? Do you want to continue?
Yes.
Yes, please.
Okay. Okay, and the second project, it's called MINEX. It is again a Horizon Europe project. In this case, it is an innovation action project. That means we are aiming at the products at higher TRLs. That means basically TRLs 6 and 7. This project started this year in January, so it's quite a new one. The consortium consists of 13 partners coming from 9 countries. And yeah, like if to describe what is the overall outcome planned, so we plan to contribute to increase access to primary and secondary raw materials, in particular critical raw materials for the EU industry. So let's, at least at the high level, to explain the main objectives. So we aim to develop basically commercial services, more specifically web-based platform that will consist of different modules. And these modules will help to increase efficiency of mineral exploration, will improve waste valorization and mine safety, and all the technology will be demonstrated at pilot sites with varying mining context. Of course, the results and the gained knowledge will be shared with diverse stakeholders, academia, and also general public. So let's look in closer way what are the activities under the MINEX project. So basically, data compilation is let's say, the basic step to improve geological modeling and to develop better mineral potential maps. For that, we want to integrate diverse Earth observation data, mainly satellite data in this case, But it is important to include also geophysical data. In this case, we have airborne or ground-based. And of course, all this data needs to be integrated with in situ data. So basically, we consider all kind of in situ data available, such as mineralogical, geochemical, petrophysical, or borehole logs data. Any kind of in situ data you can imagine. So like integrate and fuse all these data I mentioned. We want to improve the modeling, especially 3D geological modeling, and develop more accurate mineral potential maps. We also focus on mine waste. So basically, we also have been working on developing, let's say, processing schemes to make better inventorying, mine inventorying, and mapping mine residues. We also want to do improved 3D mine tailing modeling, and also to, as mentioned, improve valorization strategies for critical raw materials. Last but not least, we have been also working on tools to improve environmental assessment of mining residues and surroundings. Besides that, we also work on the approach to improve the monitoring of the mine stability. Besides that, we have also work package dealing with ESGs or as well like communication, dissemination, and result exploitation. These are kind of standard work packages now in European projects, so I won't be going in detail for that. What are the pilot sites for the MINEX project? We have 3 sites, one in Sweden, one in Spain, and one in Albania. Regarding the critical raw materials, we have like, we consider different ones at the sites I presented before. So in Sweden, Norrbotten, we are focusing on phosphorus, rich in rare earth elements, and apatite. In Spain, we have brownfield and groundfield sites. So for the brownfield, the target elements include copper, lead, zinc, together with gold and cobalt. And the greenfield, the site is actually part of the Iberian Pyrite Belt, and we are focusing on skarns and vine-hosted mineralization. And in Albania, we have a small, tiny site that is focusing on CR, what is the element? No, it's important to say that the platform we have been developing is, let's say, heart of the project. That means all the data we integrate and all the tools we develop will be in part of this platform. The platform should be more or less commercial, and there will be modules for mineral prospectivity mapping, for 3D modeling, and for inventory mapping and mapping mining residues. And the last one will be actually developed for global stability assessment of the mine. Again, when we look at the diverse of observation data, we use basically all satellite data available for free, as well as commercial data provided, for instance, by Airbus or Planet. And of course, these data again differ from spatial and spectral resolution. So it means to integrate them, it's an important step. This is just, let's say, a visual explanation that of the data I was speaking about. Each of them differ from spatial resolution and have different spectral domain. Just a quick example on the first step to process geophysical data and extract the feature to improve mineral prospectivity mapping. So to sum it up, the main results or outcomes of the MINEX project are like we are aiming at developing commercial services and products for mine industry stakeholders. This is the APAP platform that will provide modules for 3D modeling, mapping mining residues, and prospectivity mapping. We will also publish online thematic mining residues map for EU countries. The country of the interest is still to be decided. And of course, like we will publish the outcomes in form of reports or scientific papers and some, let's say, events for mining industry. And yeah, like if we sum up the impact, we want to increase success rate of exploration in Europe and supply of critical raw materials. We aim at increasing stakeholder access to EU-supported decision-making tools, and we are aiming at increasing mine waste valorization and reduce environmental impacts. So these are just basic information about this young project.
Thank you so much. Veronica will be having questions at the end of the session for introducing these two projects to us. And the next speaker is Vitaly Yurchenko, and Vitaly will be telling us about also new technologies. Please, Vitaly.
Thank you. It's new, but yeah, partly overlaps with what Victoria was telling you. Yeah, first, thanks organizers for this conference, very interesting. And well, I was, desperately looking for my name in the first 10 pages of the program to realize that I was supposed to be the last two. And I was preparing to be the, the cherry on the cake, accepting the challenge, but turned out I'm not. Anyway, I'll try to keep it, as light and entertaining. The, last presentation here, every second, if not every non-fiction book I read now, it starts with a real life story. Just, every chapter starts with a real life story. So I decided to follow the trend and give you a real life story. And the story goes back to 2021. Actually, it goes back to 2017 when BHP realized that one of their assets, Yandé, which is a huge mine in Pilbara region in Australia, was about to get decommissioned because it's an iron ore mine, because the grades were diminishing. They got a lot of clay, and the leaching has been processing has been becoming more and more expensive. So yeah, it was facing the end of life. And then in 2021, suddenly in this Australian issue of Financial Review, there was this article that their hyperspectral, or their team, has found a remedy how to extend the life of mine by another 5 years, which is massive, of course. It's in a good year they were producing 68 million tons of iron ore. So it's many billions. And then the story goes on. About half a year later, same journal, Financial Review, gives a story about one startup called Plot Logic, which actually delivered that magic tool to BHP Yandé. And no surprise, they got some. They finalized the round, and BHP poured 25 mils into that startup. Just for rendering these services to them. So yeah, and we're proud to have them as our customers. So what did they do? They just made this nice box and put it in a mine. What the box was doing, it was producing georeferenced images similar to this one, showing you, the grade, where the clay was, where the iron was, and well, this picture is not from Thought Logics because they are almost paranoid about they're very sensitive about their IPs, but this is from a similar survey from another customer, University of Fairbanks. So what's inside that box is what one of my fellow geologists refers to as the greatest invention since a hammer, and that's a spectroscope. But more, it's not just a spectroscope, it's about 640 of those guys in one box, which give you the grade with scan in about an outcrop in about a minute, and give you a grade with centimeter resolution. So what is this magic thing that we produce? I'll tell you in a second. I have to tell you who we are. We are Norsk Elektro-Optikk, Norwegian Electro-Optics. A funny company actually, because we are owned by an artist, the painter, and we have this luxury of being funded and owned by a foundation. Thanks to our late founder, Tycho Jäger. He was one of the first people to make a laser, and he made a fortune on delivering laser sensors to the industry. He and his wife, Irma Salo Jäger, they were childless, so they put all those money into foundation, and we had this luxury of being able to focus just on quality and robustness of the instruments for about 10 years, no pressure to sell anything. So, and we've been delivering prototypes and sensors for pretty much every aerospace agency in the world, starting from NASA, then DLR in Germany, ONERA in France, European Space Agency. Our customers now include BHP, Vale, Anglo-American, big France, United States Geological Survey, a bunch of other companies. But yeah, now I'll bore you with the principles, how it all works, if you care. You know that every material has its unique fingerprint, spectrum. And how do we measure those spectra? How do the cameras work? It's called push-broom technology. So what we do, we look at, instead of normal objective, we use a slit, and we look at just one line on the scene. That line is then projected into a grating or prism. So what comes out is a rainbow. You remember from your physics, school physics class, the Newtonian experiment, white light goes into the prism, comes out rainbow spectrum. And then we calibrate it in the sense that the spectrum is detected on or projected on the CCD matrix or CMOS matrix of a camera. And we use one dimension for registering spatial pixels and another dimension of the sensor for recording the other colors of the rainbow spectrum. Then we have to either move the object, because we're still looking at one line, so we need to scan the object. Either we move the object or the camera. And creates a data cube. Have I pushed the wrong button? Yeah. So every pixel in the final image, if you click, you fold it on see that it's over there. Small thing. It's so if you click on the pixel or on an area, it gives you a spectrum, and then you can try to recognize, try to guess what kind of material there is, because what you see essentially is a molecular spectrum, because the cameras and the sensors, they're active or sensitive to the part of the visible light, near infrared, shortwave infrared. There are other sensors that are sensitive in the mid and low wave infrared, and the price of the sensors, it goes exponentially as you go deeper into the spectrum. Of course, then you scan it, good. What do the next? Because you sit with a huge data cube where each slice of the cube is an image recorded at one wavelength. So you need to process it. And then, so you need a software that will compare the measured spectra with some kind of reference database. But yeah, there is a huge zoo of algorithms how to do it. And of course, we chose a software called Breeze to integrate with most of our cameras, but otherwise we're very software and platform agnostic. Yeah. Applications, what makes it fun and interesting to work with these cameras, that the applications are so vast and enormous, it's so different. So everywhere where you need to know the chemical properties or molecular properties of materials, you can apply. Either domestic waste sorting, or another day, the geological mapping is of course huge and interesting domain for us. But if on another day we can be measuring the fat, protein, water content in fish fillets. So yeah, but still, geological mapping is a very interesting and important segment for us. As I said, the cameras are pretty much platform agnostic. As long as you can move the object or the camera in a controlled fashion, you can put it on an airplane. Veronica was showing some examples of satellite imagery on a drone, on a tripod in the field, and then you scan the outcrop in a lab on a conveyor belt for continuous ore grade monitor or mineral logging. Another big hit recently has been core scanners. I'll show you, I'll skip the super boring part about the different platforms and sensors and the tech specs. Whoever is interested, please contact me. Software mentioned, of course, you need that. Dun, dun, dun. So there are several ways how to treat the data, how to process them. The approaches can be either data-driven or knowledge-based, or they're called expert systems. One of those expert systems is a spectral library. It's for many geological applications. It's the starting point is the spectral library published by United States Geological Survey. Now about different scales and some examples. Perhaps the best thing that came out of the US presence in Afghanistan is this map. It's a mineral map of the whole country that USGS did. Gentlemen Raymond Kokali and Todd Hoffen, they just used the availability of US Air Force in Afghanistan. They put a hyperspectral instrument on an airplane and scanned the whole country. But this is really an unprecedented survey on unprecedented scale. I'll give you some examples and maybe give you some hints about the practical value of other applications. Drone survey. We did a pilot for this Burra pit in Tucson. It's a copper skarn deposit. The deliverables was a nation map, secondary iron, and weathering map with, again, fully georeferenced with 5 to 10 centimeters resolution on the ground. Yeah, there you of course see all this, they're called end members, they're the minerals. But yeah, probably the most interesting is this map. So the result was, again, the complete map of minerals like jarosite, showing the, given a much better, much more detailed picture on mineralization, secondary mineralization, secondary iron, and whatnot. I see I have just about 1 minute left, so I'll briefly go through some other examples. So we've seen how it works with the drones and what you can expect from the drone data. For most operating mines, this drone data is, yeah, it's interesting, good toy to have. But for their daily operations, it's, well, I don't know. There is definitely a value, but more practical solution is mine face scanning, if we're talking about open pit mines. Here's an example from work by my colleague, Friederike Korting, during her time at GFZ. It's VMS type of deposit, copper gold. The result of the scan was a map with the grade of copper, very similar to what Plot Logic delivered to BHP, and ended up with 25 mils in their pocket. Yeah, core scanners. Another way to apply hyperspectral imaging. If you put the cameras inside this moving box here, just to throw some practical figures at you. So we scanned in this pilot, we scanned 49 boxes for this Laurent de Pena operator. Time per box 3 to 6 minutes scan, and what you get, a complete log of all your cores with sub-millimeter resolution, huge amounts of data, but what you actually need is just depth registered log of metadata. So minerals, abundance, numbers, percentage, which you cannot see, I'm sorry, but that I would make the resolution different, but yeah. And yeah, last, almost last. Yeah, oh, sorry, I'm over time. Is that okay? Can I take another minute? Thank you. So we were recently in a very interesting project. It's a huge limestone mine, aggregate mine, one of the biggest in the world. We were in the middle of their digitalization project, where it was really an eye opener. So we delivered to them several systems. First for lab and pickup truck. So what they do, it was really interesting. For me, at least, as a layman who has never been in real mine operation. They had a time gap about 24 hours between drilling, blasting, and grading, because just to deliver the samples to the lab, analyze them, return the feedback to the operations, updating the block model, and putting the grade on a particular block. It would have taken them about 24 hours. Some grades, well, some customers are really sensitive to the grades. So what they were doing, they were selling cheap, high-grade material, but because the production never stops, although it takes 24 hours, they start producing the moment you can access the blasting site. So here we delivered a scanner that can be installed on in the back of the pickup truck. They scan the drilling chips in the field before the blast, and before the blast they can already update the block model, so they know the grade with much better precision. Of course, they are no newbies. They've been doing their guesswork based on the geological assessments. So yeah, they were working. They had their routines, but we shrunk that turnaround time from blasting to the production from 24 hours to minutes. And that's a lot in terms of revenues. Then still, to make it more actionable, you need to be able to say you scan, the grade, and then you need to be able to divert, for example, whole trucks from to the right crusher with the right grade. So we put another system just on top of this IPCC, and we've been scanning the whole trucks, giving them the mineral composition, of course, of what's on the surface, but still it's an order of magnitude in terms of data granularity compared to one drill hole per 25 square meters or more. And the last thing was, the cross-check after it's crushed, next level of granularity. We put a camera on a conveyor belt, and that was a continuous stream, just monitoring of what's on the conveyor belt in terms of grade, minerals, and et cetera, et cetera. And yeah, the same for the mine phase. And the last thing, to show you the multi-scale data, because people often ask us, how does it, can you use satellite? And yeah, I'm already over the time, but yeah, don't blame me. I thought I have 2 time slots, so I'll just show you the comparison of post-life monitoring of how it's called, not reclaimed, recovered uranium mine in Australia, also Mary Kathleen. So we we flew a drone over it with a hyperspectral camera, and the hydrological situation there is so that after they have this ephemeral rivers. So after rainfalls, the water levels, the groundwaters also go above or out of the normal aquifer, and they spread the reactive material around the former tailings. Yeah, we mapped how this spreads compared year on year, and here you see the comparison actually of drone and UAV data. It's very tempting to use satellite, the drone and satellite data. It's very tempting to, just get the satellite data relatively cheap and then do large area monitoring. But there are a couple of pitfalls here. First, if you have any vegetation, it will mask the ground. It will, and the larger is your pixel, because the UAV pixel is on the ground. It has resolution 3x3 to 6x6 centimeters. So you can sort out a lot of vegetation. And after masking out the vegetation, even with the drone data, we were left with like 50–60% of the pixels available for analysis. With the satellites, it was down to 10%. And yeah, but the final product was year-on-year comparison of contamination areas. And I'm done. Thank you very much, and sorry for taking a bit too long.
Thank you so much, Vitaly. You managed to have in the same talk defense, also foundation on by an artist and NASA. So I hope to have very good questions at the end. And the next speaker is Niasz Livniak. I hope I'm pronouncing well your surname. Yes, you will be talking about hands on the ground. So what we are really doing in your company. Welcome. Something concrete.
Yeah, exactly. Yeah, good afternoon, everybody. since I'm the last speaker, I would like to take the opportunity to thank Arthur and the team for another event that indeed generates lots of benefits for us. But as I had a quick chat with Paul from Europa Minerals in the hall outside, maybe at least some of the next events you should think of organizing in Brussels, because lots of rather pessimistic messages today we heard, and we guess that the address for those messages is there. Anyhow, so today I'll speak about GEOPS, our company that indeed has its hands on the ground. And before I start, I would like to remind all of us of the importance actually of drilling and drillers as players in the exploration segment in general. So what we have on the left is a photo that symbolizes some modern advanced world that we all strive to. But on the other hand, what would it be without drillers and drilling? Apparently, many of the resources would be missing, and lots of targets that we have in front of us from now on would be under huge question mark. No copper for wiring, no lithium for batteries, no critical minerals for infrastructure, no oil and gas for energy, no water from deep wells, and lots of everyday, lots of essential materials for everyday tools like smartphones, for example. So indeed, we would end up in some prehistory, like the bedrock from the Flintstones. And as much as it looks funny, actually, it's realistic, and we should face some things that are in front of us. No lithium, no batteries, no lithium, as we said, meaning electric cars that we so much talk about, not only the EVs, but many other things, but EVs in this particular context would be a thing of past, actually, not the future. And we'd all be getting some serious leg workouts. Yeah. Obviously, although it looks fun, we should all agree that we're all better off, and we should be better off with drilling and drillers and exploration and look forward. So, speaking of GEOPS, it has been founded 20 years ago. These days, actually, we celebrate 2 decades of lots of activities, lots of experiences, lots of challenging projects, and we proudly stand with like 450 people in the team with experience and expertise that extends far beyond Europe. We are present from Portugal to Kazakhstan, from Cyprus to Scandinavia, and 20 years of business means for us 20 years of passion, expertise, dedication to the future of mining exploration industry, indeed. At GEOPS, our services encompass a wide range of drilling methods and practices designed to meet diverse needs of our clients across different stages of mining and exploration. In terms of method of work, we provide core drilling, standard drilling method, reaching up to depths up to 3,000 meters. Then directional drilling, percussive drilling, of course, rotary for high speed. And on the other hand, in terms of purposes, we do serve exploration projects, production as well, also technical drilling, etc., etc. Some milestones, as I said, we've been founded actually 20 years ago, and we began humbly with one rig, but already by 2009, we became a trusted contractor, mainly in the Balkans, which is our priority region. At the moment, only in Serbia, we have like 15 rigs in operation, and this is for last 2 years, like ongoing. So it's a huge campaign over there. We also launched our first in-house workshop 2009. Then 2012, we emerged as the top contractor in the Balkans with 20 plus drill rigs. And 2017, we started expanding across Europe. We ventured also into core drilling and in the oil and gas environment, added large diameter core drilling, and also conducted some projects in North Africa. By 2022, we had grown even further, with reaching 45 drill rigs that we have in the fleet at the moment. All ranges from small portable ones to the big ones of 100 tons. So our main driving engines, we would say, are actually primarily the thing that we operate globally, so in a wide scale, but in the same time, we run locally, meaning we are indeed present on a large scale in various markets, but more important is that we have established over the course of past several years a diverse network of local partners. So wherever we operate, we have strong local partners to support us, subcontractors, and that enables us to adapt quickly and overcome different kinds of challenges at different markets. Secondly, our people are our past, present, and future. It's all about the people. We're proud of our employees, and it's actually their commitment and knowledge and something that's kind of like daily improvisation, looking for solutions. It's something that enables us to go forward and keep growing. And of course, partnering with many international companies. Like this is just a small portion of our network of clients that we are indeed proud of, and that actually in some sense helped us grow and improve. As we continue, we face different kinds of challenges basically on a daily basis. That's drilling. Each and every drill hole is different, even though if it's just 20 meters away from the previous one. So we deal with these daily challenges and with different kinds of methods. One challenge that was very interesting as a project itself was one large diameter hole that we had conducted for Rio Tinto in Serbia. You can use the QR code to look into the article for additional details, let's say, but briefly, from one borehole, we had extracted 37 tons of core. So it was something different, and proudly we can say that entire tools used at this borehole, at this single project, was produced in-house by our manufacturing unit. So as challenges, what we can mention, of course, is the market. Even today and yesterday, we heard so much about all the fluctuations, all the vulnerabilities that we all face, and we as drillers as well, we are affected indeed, but again, we managed to adapt, we managed to overcome, and we hope sincerely that primarily in the European Union, things will move a bit faster for all of us. At GEOPS, we believe that a well-trained team is the foundation of success. It's all about the people. Our training programs are designed to meet different kinds of industry demands, fostering a capable and motivated workforce. We recognize the importance of supporting our senior staff, so pushing them to keep on learning, keep on advancing, staying in touch with all the modern geeks and advancements. But in the same time, we have something what's called Intern to a Driller program, attracting young generations, new people, young boys to take a step, dive into the drilling business, and we support them, we help them, we provide them all kinds of trainings to grow from a intern as a drilling helper, drill master helper to drill master to supervisor, and furthermore. And we are proud to say that of these 400 plus employees, most of them pass through our program of development, career development, and all of our drill masters with 10 plus experience have actually started from zero. Then, in terms of the technological advancements, we also try to be online to try to answer in a best possible way. And one example is our own drilling operation software that we have also developed in-house that helps us to be significantly more efficient, more productive, for sure, but also very important, more transparent to our clients. So they have full insight in time of what we do at their projects, how we perform, and take good reports as such. Absolutely, big focus, big emphasis is on health and safety, which is crucial. We take a comprehensive, I would say, approach to risk, broadening our perspective to gain a true understanding of health and safety challenges. And each task, each activity is taken separately, tailored to the specific site, ensuring that we address unique risks effectively and eliminate consequences. We place particular emphasis on mental health as well, and stress management, recognizing that a supportive environment is essential for our team's overall well-being. Several years ago, we managed to, primarily with the support of colleagues from Rio Tinto, to implement a procedure, a take 5 procedure, pretty well known in the health and safety segment, and still we successfully operate under it. Same approach we have, of course, in terms of the environment, which is a big topic, and our zero harm commitment policy is essential and fundamental to our operations. Our approach includes implementing energy efficient practices where possible, of course, and adopt green technologies as well where possible. We also focus on low impact exploration methods that significantly reduce surface disruption. I hope that you will have chance sometimes to pass by our drill sites to see how we set up the rig, the supporting equipment, how much effort and tools we use to protect the ground, with different layers, to prevent all kinds of spillovers or whatever to affect or damage the ground, how we do the recultivation of the sites. Our clients, local authorities are happy with that. So that's something that we are, of course, proud of. Looking into future, GEOPS takes bold yet measured steps, I would say, toward growth and innovation in different segments. Primarily, our workforce is our big focus. This slide tells you very much about it. So drillers are most wanted. We look after them. We try to keep the ones that we have in our team to time, and it's them who actually enables us all to keep on going forward and actually keeping us all out of the Stone Age, but literally. So obviously we might not be like riding dinosaurs or something, but we are still digging deep, evolving, and ensuring that our industry stays ahead of the times. It's a task for all of us. It's a tough job, especially drilling, but someone's got to do it. And we are looking forward to all the projects, all the challenges in front of us to cope with them. And we are ready to rock and to join with us on this journey, all those who have the same goals. So at the end, once again, I want to thank to everyone participating, the MINEX team, and again here, QR code is for the contact information in case some of you need to reach us over. So thank you very much.
Okay, thank you so much, Nias. I wonder, I mean, we were listening to, and I took some notes, satellites, artificial intelligence, scanning, coreless technology, which of course is a problem if your business is taking out cores, but I'm assuming that resource estimates geologists and investors are also worried with coreless technologies, but also hyperspectral. And I have two questions for the audience. Because you have been here for so long and you are really, I mean, the coffee is good, but of course we also deserve, you also deserve our praise for taking the time to be listening to this. Do you think that these technologies will be used in exploration, let's say in 5 years from now? Not many people, I see. And in mining, 5 years from now, in the extraction, I mean. Less sense, not many less. Okay, so I guess that we have like a good setting for questions. I'm assuming you'll be having some questions. And I also understand that we are between you and dinner, but we might have like 10 minutes for questions. Is that okay? No questions? Okay, everyone is worried. I have one for each speaker. Okay, first one. If I may, to Marco, because you mentioned something that was reducing the size of mining works. I mean, is this something that will change the way we are mining today using robots?
Well, robots, especially small ones, most definitely can reduce the amount of material excavated. The first place, since we would, in ideal world where we would be able to develop a robot like that, would actually fit maybe even a vein to follow while it explores it, could also ideally process it and leave the residue behind and somehow produce us with the final outcome that we all strive for. I mean, I know that's a science fiction for now, but somebody told me today I'm too optimistic. I'm still optimistic that let's say in a couple of decades we could get to that level. So yes, I think we should strive to reduce the size and mine material excavation, because with that we would also answer some of the questions that are constantly posed ahead of the mining industry from general public, that is pollution, residue, waste, etc. So I think we have a huge challenge ahead of us, but again, innovations are there. We just need to find them and explore them in mining.
Thank you, Marco. If you have questions, feel free to step in, because I mean, what you mentioned might be really a game changer. That's my perception. At the same time, Veronica, you were talking about Earth observation in these two projects that you mentioned. Do you think that in the future we'll be basically relying on satellite images? And I mean, in a way, that will speed up exploration, but would we still need geologists, or this is something that with all these satellites and I mean, will be going faster than what we are doing now?
Yes, like as you know, satellite data, we basically are able to characterize the surface. And of course, exploration is also like dealing with lots of subsurface. So that's why we need to integrate together different data coming from different sources. But anyway, definitely satellite data can improve lots of monitoring, let's say, approaches, and yeah, like it's data are here. Data are available for free for everybody in most of cases, and now it's the time, in a way, to take advantage of that.
Because in the second project, you mentioned that you'll be doing that integration, because
Yes,
between data from
also,
the surface,
yes, yes.
and is that something that will be publicly available to the people?
Well, as I described, the iPop and the modules will be commercial for this 3D modeling and like data and geophysical data integration, such. Yeah, that's how the project is, let's say, set up. So
Okay, something then to
yeah,
follow
have a big
on the
commercial.
website, I'm assuming, to see
Yeah.
what you are producing. Okay, thank you, Veronica. Vitaly, I was really impressed because you have something that you can put on the back of a truck. In your example, I believe, from the aggregate company, and basically it's screening and like real time providing this sort of data. So I wonder, what type of scales are we talking about? Because you mentioned that the size of the pixels, you mentioned centimeters. I mean, is this something that works with different scales?
Yeah, thank you for the question. Actually, it all depends. All depends on the distance between the camera and the object, pretty much, because the cameras have their angular resolution, and if you put it on a satellite, you will have a few meters on the ground. If you put it on the conveyor belt, you will have a millimeter or a few millimeters resolution. But the cameras are very versatile. So, and it's just the angle and the distance to the object. I'll just give you the scale from meters to 25 micrometers. That's the resolution.
The range. Okay, impressive. Because as you mentioned, it might be something that goes way further than the hammer. I mean, as a geologist, I still have an hammer, so I haven't tried that. Thanks a lot. And no questions still from the audience? No? I mean, Niyaj, I wonder, because you are still working, let's say, doing, extracting the cores and all these things, is this technology something that your company might be uptaking? I mean, is this already changing the way you are doing business? Because you mentioned health and safety, for instance. But do you think these technologies could be uptaken to other areas?
Not much, I would say. Not much impact to the work that we conduct. It's, I think, again, at the end of up to geologists to provide us, maybe through that way, that side,
for the geologists to have better data and then to provide, to forward it to us so that we are a bit better, prepared or how to say, planned to conduct the drilling itself in the end, because obviously it matters a lot if we get a valuable, credible data of what rock to face down there instead of just being on blind. So from that side, it might be helpful. Yeah. Other than that, then we are just on our own.
That's true. That's also my impression, but this is my personal opinion, because with that resource estimates, we'll need to, you need to go there and touch.
Absolutely.
Okay. Thank you so much. Thank you also to the audience, and applause to our speakers. Thank you.